Assalamualaikum. Today I want to teach you how to sketch shear diagram, bending moment diagram and axial thrust diagram for this parabolic arch. Okay, so you can see at your book provided. So last question need you to draw the shear force diagram, bending moment and axial thrust diagram. So from this diagram, we can see that there are external load 100 kilonewton at point A to D at 25 meter from A. So the rises is 16 meter and length of span is 100 meter. So inside your book there is no E here. So the purpose I put E from B, 25 meter from B is because I want to look the changes. If there is 100 meter here, 100 kilonewton at D, 25 meter from A, so what is the changes at E? Okay, so first we need to make a free body diagram. So AY, AX, BY and BX. So you have to find AY, AX, BY and BX. So first, we have to calculate By by inserting into the total moment equation. So 100 times 25 minus By times 100. So By we get 25 kilonewton. So Bx cannot inserted into this equation because of Bx is same line with A. So there is no distance for Bx. Then total Fx. So there are only two horizontal force, so AX and BX. So AX is equal to BX. And total of Fy, so AY minus 100 plus BY. So we get AY and equal to 75 kilonewton. And then we does not solve only AX and BX. So we have to consider either left hand side or right hand side. So I consider left hand side with the 25 meter here. Okay, I put the AY that I get previously. AY equal to 75 kilonewton. So taking moment at C, 75 times 50 minus AX times 16 minus 100 times 25. So I get my AX is equal to 78.13 kilonewton. And we have to acknowledge, we know that AX equal to BX, so acknowledge the AX equal to 78.13 kilonewton and BX also 78.13 kilonewton. Okay, continue. Since the equation need you to find for the whole diagram, so that we have to find out Q, M and N for every each A, D, C, E and B for every each point. So we start with A. Okay, since A is X equal to 0 meter, which is A located at origin, so A also has a degree. Okay, so we put X equal to 0 meter and then put into equations of slope. H is equal to 16, L equal to 100 and X equal to 0. So we get theta is equal to 32.62 theta degree. Okay, how to resolve at point A? So we refresh back. Okay, so if you want to resolve at point A at the left hand side, so left hand side, this is the diagram. So the theta is at the left, so theta here at this vector is left and this one is left. So we taking this out. Okay, so the diagram equal. And then we have to find Q and this N. Okay, put correctly this AY and AX. From this diagram, okay, we have to resolve into Q and N direction. So in this exercise, I take this downward is positive. So see into this red arrow. So this one is positive downward, this one is positive, this one is negative. Okay, so Q plus Q, so this one is 78.13. Because of this one is far from theta, so this one is sine theta. So this one is 75. Because of this one is nearest theta, so this one is cos theta. So into this equation, put into the equation, so Q is equal to positive 78.13 sin theta minus 75 cos theta. So we get Q equal to 21.05 kilonewton. And then we have to resolve in N direction. So I take this direction is positive. So this direction is positive. So this one is negative. This one is negative. So N minus 78.13 cos theta minus 75 sin theta. So we get this equation. So we get N is equal to 106.24 kilonewton. Okay. So next, we have to proceed with point D. So see, this point D have a load 100 kilonewton. So we have to do both with and without load. So first we have to do without load. It's okay, you can do with load first. Okay, so but I will do without loading first. So the point D is x equal to 25 meter. So Q is positive in this direction. So this one is positive, this one is negative. So put into equation. Okay, sorry. First, you have to find out the punya y. Y is equal to 12 meter. We get y is 12 meter. So find out the moment. So moment is equal, moment at D is 937.44 kilonewton meter. And then find out the slope. The slope we use x equal to 25 meter. And then we get theta is 17.74 degree. And then I use resolve is downward is positive. So Q plus 78.13 sin theta minus 75 cos theta. So we get this Q is equal to 47.62 kilonewton. And then my N is equal to 97.27 kilonewton. Okay, proceed with point D with load. So we just add on this 100 kilonewton on top of previous diagram. Okay, we draw back. If you look at in this diagram, the equation here, okay, only you add on from okay, you see here from previous equation. Okay, and then you put 100 cos theta here. Okay, also for N direction, so put 100 sin theta here. Okay, the resolving direction is equal, so this one is left, so theta is also at left. So this one is 100 cos theta, this one is 100 sin theta. Okay, proceed with point C. Okay, point C, actually there is no theta here, theta equal to 0. You may prove it by the equations of slope. You may get approximately 0 for this theta, 0 degree. So put the value as of AY, AX and 100. So this Q is in this direction, so this one is N. So Q is same like this direction, so this downward is positive, so I got this one positive, negative. So Q plus 100 minus 75. So you get Q is equal to negative 25 kilonewton. So also for N direction, so you have N minus 78.13. So you get N is equal to 78.13 kilonewton. Okay, we proceed with point E. Okay, because of point E is same X, same distance from origin. So the origin at point E is B. So X equal 25 meter. So theta is equal with theta D, 17.74 degree. So Y also similar, 12 meter. And then taking moment at E, so 25 times 25 plus 78.13 times this one is YE. So you get ME is equal to negative 312.56 kilonewton meter. And then you have to resolve in Q and N direction. So Q plus Q cos theta, 25 cos theta, minus 78.13 sin theta. So you get Q is negative 0.005 kilonewton. So this one is approximately 0. And N you get 82.03 kilonewton. And then you proceed with point B. Point B is equal to 0 meter. So similar with point A, the degree of theta A. So you get 32.62 degree. And then moment at B equal to 0 kilonewton meter. So resolve it. Same like this one. Okay, resolve like this one. So you get Q is equal to 21.05 and N 79.28 kilonewton. Okay, lastly you have to put all the value that you get, Q and M at A, Q and M at D, Q and M at C, also Q and M at E and B. Okay, too easy for me, I put it here. So it's okay if you not put the value at the diagram. And then we sketch the shear diagram. So this is the diagram. Shear diagram. So I got 21.05 at point A. Shear diagram for Q. And then 47.62. Then pointing downward. This one is with load. This one is with load. This one is without load. And then you get 25 negative 25, negative 0.005, and 21, positive 21.06. So you sketch like this one. And then for Azure Trust diagram, you get 106124, and then 97.27, 66.1.8, and then positive 78.13, 82.03, and 79.28. And then for bending moment diagram, so actually this bending moment diagram, you can predict what is shape of bending moment diagram. So if there is a beam, so pointing downward, so bending moment diagram like this one. So for arch, it's slightly bent, hogging. So it's like this one. Okay, it's curved here. So the value of this one curve, you may predict the shape. The shape will be curved. So either on top or at bottom. So you may predict. So that's why you have to calculate what is the value here, what is the value here, or here. So from the calculation, I get for point D, this one A, D, C, E, and B. So first, you have to draw for 0 for A, 0 for C, 0 for D first, B. And then you get point D, the moment is 937.44, positive. And then E, negative 312.56, negative. So because of you get this value, negative, this one positive. So the curvature is like this one. It's okay if you get you want positive on top and negative like this one. So the shape like this one lah, should be like this one. It's flipped like a mirror. So this one also correct. Okay, some of the books, the positive for bending moment is on top, and the negative is at the bottom. So both are correct. I accept for both. Okay, thank you. So our lecture today is only about how to sketch shear force diagram, Azure Trust diagram, and bending moment diagram. Okay, thank you very much for your time and attention.